Hello, and welcome to 5 Minute Math. Today we are looking at the 7th grade concept of area of composite figures. This is 7.9C Readiness Practice, the advanced version. If you are interested in exploring the 7.9C Readiness Practice for the intermediate or proficient versions, or the Readiness Practice resource along with any other standard, you can find those by using the link in the video description. So we have a 3/4 circle connected to an isosceles right triangle. So we can put a little square right there. And the diameter of the 3/4 circle is 5 centimeters. So let's draw this right here. And from side to side, obviously through the center is going to be 5 centimeters. We also have it up here. Now, each leg of the triangle, now when we're talking about legs of a right triangle, those are the two sides connected to the right angle. So each leg is the same length as that diameter. And so it's isosceles, which means these two legs are identical. So we can say that this right here is also 5 cm, and that this right here is also 5 cm. So we have a lot of 5 centimeters here. So we need to find the area of this composite shape that's got the right triangle and the 3/4 circle. Well, let's find the area of each, and we're just going to add them together using the additive property of area. Let's take our circle first. That's going to be a little bit more interesting. So we don't have a formula for 3/4 of a circle. What we have is the formula for area of a circle. All right, so it's going to be pi r squared. And simply because it's 3/4, what we do is we end up just writing 3/4 in front of it. So we take the area of what a full circle would be, and then we just multiply that by 3/4. All right, so what is our radius? Our radius is half of 5, so that's going to be 2/5, or 2.5, excuse me. And we can make that, if we want to, let's just, since we're dealing with fractions right now, let's go ahead and let's just make it 5/2. Okay? But it's not just 5/2, it's 5/2 squared. So if we want to simplify that, we've got 3/4 times, and then 5/2 squares is 25, excuse me, 25/4. All right, so ultimately what we have here is we've got, if we multiply our fractions with each other, right, we've got 3 times 25 is 75 sixteenths divided by pi. Now, that's the most accurate way to represent this, but we need to go and round it to the nearest hundredth. So let's go ahead and just multiply this. Now, we've got a few options, right? We could go ahead and divide 16 by 75 and multiply that by pi. Probably what I'm going to do. So let's divide our 75 by 16 instead. 16, let's see, that's going to be 4 times, I believe. Let's see, 24. 64, because yeah, that 5 times is going to be 80, so let's do 4. And that's going to be 64. That's 11. Let's get a decimal here. Let's see, 80, 96, 5. 6 times would be 96. 7 would be 112, too much. So 6 is going to be 96. It's 14. Let's go one more. And that's going to get us to the 100th spot. And we're good with the 100th spot because we still have to multiply by pi. We're going to use 3.14 for pi. So 16 goes into 140. See, 9 is going to be 144. So let's do 8. And that's going to be 128. I just took my 64 and doubled it because 16 times 4 is 68. So if I double that, I'm going to get my 16 times 8. And it goes on and on and on. But let's just deal with that. So we've got 4.68 times pi. So equals, and then now instead of equals, what we're going to do is we're going to kind of put approximate here. 4.68 times, let's substitute in our 3.14. And so let's go ahead and do that. Put a little space over here. 4.68, 3.14. And let's see, that's going to be 32, 24, 27, 16, 18. Right here, we're just going to write 468 because you're multiplying by 1. And that's going to be 24, 18, that's 20, 12, that's 14. All right, so 2, 15, that's 19, 6, 14, 1, 2, 3, 4 digits behind the decimal, 4 digits behind the decimal. So we are going to round this to the nearest hundredth, and that 5 is going to make that change, so let's call that 14.7. All right, so we are at about 14.70, but we don't really need that last zero, and we're dealing with square centimeters. All right, that was the hard part. Now let's deal with our area of our triangle. And remember, it's 1/2 base times height. Since this is a right triangle, what we could do is we can use one of the side lengths as our height because it's 90 degrees with a base. So we're going to call that 1/2. The base is 5 and the height is 5. So half of 25, or 12.5 square centimeters. And then what we do is we simply add those two since we're using the additive property of area. We're going to say 14.5, 14.7, excuse me, 12.5. Add those up, and you're going to get 12. That's 7. That's 2. 27.2 square centimeters is our approximation for the area of this composite figure. Let's put that in a green box because that is the answer. For number 2, we have a park logo that has a design that looks almost like a banner, but it's got a rectangle, some parallelograms, and some trapezoids. And we've got all of our dimensions here in the bullet points. We need to find the total area. So we're going to use the additive property of area. Let's just find the area of each of these smaller shapes and add them all together. So we have a central rectangle that is 20 by 10, and we're dealing with meters. So that's going to be base times height. So that's going to be 200. And then we are dealing with meters. So let's put square meters there. All right, that's pretty simple. Each parallelogram is identical. So let's look at we've got a 10 meters for our height. And we can kind of put that there, right? If we needed to, let's make that a little bit more, there we go, perpendicular to the base. There we go. And we've got a length of 12.5. All right, so I'm going to mark that up here. Now we also have a base times height. So area equals base times height equals 10 times 12.5. So we're dealing with 125 square meters. I can put that over here as well. 125 square meters. Now let's look at our trapezoids. So we got the shorter base that matches the height, right, because we're dealing with 10. Longer base is 13. And then our height here is going to be this way, and it's 3. All right, so our area here is 1/2, and then we have to add the two bases. Base of 1 plus base of 2 multiplied by height. So we've got 1/2, 10 plus 13, and then multiplied by 3. So what do we end up with is we end up with 1.5. I just took the 1/2 of 3 times 23. So we got to do a little bit of work with that. Let's multiply 23 times 1.5. That's 15. It's 10, that's 11. And then we just add the 23 there because we're multiplying by 1. And it's going to be 345. Add that decimal, 34.5. So this is 34.5 meters squared. This also is 34.5. meters squared. What is the total area? Let's add them up. I do have some decimals, so I'm going to put a decimal there. 200, 125, 125, 34.5, and 34.5. So that's going to get rid of that decimal there. So 5 and 5 is 10, and then I've got 19. I've got 3 and 3 make 6. 2 more make 10. Or 2 twos make 10, excuse me. And I've got 11. 1, 2, 3, 4, 5. 519. All right, so 519, and let's get our unit there. Square meters, that is the total area of the logo that needs to be painted. And finally, for number 3, we've got a circle, and then it's got a square cut out. And so let's just find the area of the vinyl, right? So that vinyl is going to be the remainder of the circle is going to be covered. So let's use a different color here. What we're looking for is the area of this shape right here. The circle minus that square. Okay, so that's what we're going to look for. Area of the circle minus the area of the square. And then we need to round to the nearest penny because there's a little bit of a cost. Once we find that area, we have to multiply that by $1.35 per square foot. So let's find the feet first, and then the square feet first, and then we're going to do a little bit of multiplication. So what is my area of my circle? Well, I've got a radius of 4.5, so that equals pi r squared. And then that's going to equal pi times 4.5 squared. All right, so time for some multiplication. Let's do 4.5 squared first, and then we're going to multiply that by 3.14. So that is going to be 25, 20, 22. And it's going to be 20. That's 16. That's 18. 25, 10. That's 20. We've got 1, 2 digits behind the decimal. So 2025 is my radius squared. Now I need to multiply that by pi. So let's go ahead and just go straight into 3.14. And that's going to be 20. That's 8. That's 10. And that's 8. All right, so second row is just going to be 2025. Third row, 15. 6, that's 7. That's a 0, and that's 6. So 0, 5, 8, 15, 3, and 6. We've got 1, 2, 3, 4 digits behind the decimal. 1, 2, 3, 4 digits behind the decimal. So we can say that my area of my circle, assuming that we don't have that square cut out, we obviously do, is going to be 63.585. We'll go ahead and leave it to the thousandths place right now. We will round a little bit later. And this is going to be square centimeters. 63.585. All right, let's do the area of the square. Now, area of the square is pretty straightforward, you would think, right? Equals the side squared. Now, the square's side length is 1/3 the diameter of the circle. Okay, so 1/3. What's the diameter? Well, the diameter is double the radius. So 1/3, and then we can put double the radius, 2 times 4.5. And so let's simplify that because it's not as hard as it looks. 1/3, 2 times 4.5 is going to be 9. So that's just going to be, what is 1/3 of 9? Well, that's 9 over 3. That's just 3. 3 squared equals 9. All right, so not as hard as we thought it was going to be. So then let's just subtract the 2. We've got 63.585. And we're going to subtract 9 from that. Make sure we put that lined up with the decimal. 585. And then that's going to be 54. Now, I'm going to go ahead and that's the area of this shape right here. Put that in that box so we can at least know that that's the area of the composite shape. But we're not done yet. I'm going to go ahead and just drop that last 5. I'm going to round that to 54.59 because now I need to multiply. And I need to end up rounding to the nearest penny, right? So we have to multiply this times 1.35, and that should say square centimeters, right? We are going to multiply the 54 times 59, and I'm going to multiply that by $1.35 per square centimeter. So what we have here is we are going to just multiply, and then we're going to end up rounding our answer to the nearest penny, which would end up being the hundredths place. So that's 45, it's 25, that's 29, 20, 22, that is 25, 27. Let's get rid of those. I've got 27, I've got 15, 17, I've got 12, that's 13, and then I've got 15, that's 16. And then I can just write my 54, 59, that's 5, 16, and that is 19. And let's see, I've got 10, 16, 10, 13, 7, 1, 2, 3, 4. So we need to round this to the nearest penny. And so let's say $73. And that 69 is going to be rounded up to 70 cents. That is our final answer. If you are interested in exploring the 7.9C readiness practice for the intermediate or proficient versions, or the readiness practice resource aligned with any other standard, you can find those by using the link in the video description.